Hello, this is Nsei Obat. I just wanted to share with you the interview preparation process that I took to get an offer from Amazon. So the first thing I'm going to show you is a site called neetcode.io. On this site, it takes you through the Blind 75 or the NeetCode 150. The Blind 75 is a list of problems that is used in the industry to help teach certain underlying patterns in these kind of interview questions. So what neetcode.io does is arrange all of those questions into a format that allows you to clearly see what the underlying patterns are for each set of problems. In general, those patterns are arrays and hashing, two pointers, sliding windows. You have stacks, all sorts of data structures, stacks, lists, trees, heaps, graphs, and different types of algorithm, like simple binary search or more advanced algorithms like dynamic programming, greedy algorithms, and so on. One problem I want to show from this list that I think will really help you to understand what's important in the interview process is the two-sum problem. Originally, I was going to write out the three different solutions that I'm going to discuss and all the reasoning behind them, but it's apparently quite difficult to do that in under 10 minutes. So in the interest of time, I've prepared all those solutions. During your interview, the first thing you want to do when you're given the problem is to actually read the problem. That sounds pretty obvious, but you'd be surprised how easy it is to miss lots of details when you're really stressed during an interview. Also, after you've read the problem, you should talk to your interviewer to make sure you understand all the details regarding the problem. So let's read through the problem. Given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. The first solution that comes to mind is to look at each element and for each element to consider all the other elements. This solution requires that you do n operations n times, thus would be an n squared solution. So I've also pulled up the BigO cheat sheet, and on here you can see n squared is generally considered a horrible runtime. For some problems, especially advanced problems, n squared is actually often a decent runtime. However, in general, n squared is a horrible runtime. So we should try to find something a little bit more efficient. However, just to show you, I have what I believe is an n squared solution written out. So I iterate over all of the numbers and do all n operations n times. So that's this nested for loop, which gives you n squared. One way we can improve is to sort the elements. Sorting will allow us then to use an approach where we can consider the fact that all of the smallest elements will be on the left and all of the largest elements will be on the right. And since sorting takes n log n, again, which can be confirmed on the BigO cheat sheet, sorting is n log n. Then we can build a solution from the concept of sorting, which should be n log n. So I sort the elements. We won't get into details about the tuples. And then I iterate over the array simultaneously from left and right at the same time. Again, I wish I could spend more time getting into all the details. And eventually we find the target. This process here takes n amount of time using a two-pointer technique to go from left and right simultaneously. And sorting takes n log n. Since n log n is a greater runtime, it dominates the total runtime of the algorithm. So this algorithm would be BigO n log n. Although that is not the optimal solution. The optimal solution to this problem is actually O of n. So to achieve that, it helps to think in terms of data structures. In particular, the data structure we'll utilize is a hash map, or in Python, a dictionary. And what we store in our dictionary is the number. We use the number as the key and its index as the value. And when we're searching, we use target minus the number to search what is already in the dictionary. So I hope showing you the thought process of going from brute force solution, so a suboptimal solution, to an optimal solution, helps you to better understand the kind of thinking that your interviewer is looking for. So good luck and happy coding.